Okay, now we're going to make a discharge measurement with the RiverSurveyora. Today we have the M9 hooked up to the power control module with RTK GPS. But the purpose of this session is we're going to talk a little bit about the site location and the technique of making a discharge measurement with a RiverSurveyora. The first thing, and probably the most important thing to consider for a successful measurement, is the site selection. Okay, again, we're down here on the Pangolo River in South Africa. This is a test site for the Department of Water Affairs, and they've been coming here for several years. So after several measurements, they picked this location to measure. That's why we're here today. But if we were coming here for the first time, one of the nice things about this RiverSurveyora is that we can actually collect data up and down this river to find the best cross-section. So what are we looking for with a good cross-section? Typically, if you can look out over the river, you can see that the river is flowing through, the flow in this river, this cross-section is fairly uniform. Okay? So we want to try to avoid a sharp bend or turbulence or rocks or trees, anything that might obstruct the flow or obstruct our ability to cross the river. The next thing about the actual setup, again, it's a very versatile profiler. You can attach it to a lot of different types of platforms. Here we are on a boat here with a motor, but we can actually tow, and we're actually towing the hydroboard. Okay, so in this case, the important thing to remember is the stability of the transducer as we go across the river. Okay, so as stable or as stable as we make this measurement, the better our results will be. So when I make the measurement, I'm going to start somewhere near here on the edge of the river at a good starting location, and I'm going to start collecting data, and as I cross the river, you'll see I'm going to try to maintain a very slow and very steady motion across the river. When I get to a safe distance on the other side, I'm going to stop the measurement and then restart the measurement and collect data coming back. And we're going to repeat, we're going to go back and forth across the river, typically 4 to 6 times to collect an average discharge value. Okay, I've got the boat in a nice stable area along the right edge of the water. I'm going to take, the first thing I'm going to do is I'm going to measure my distance from the transducer to shore. Okay, that's 11.8 meters. I've got RiverSurveyora running right here, and I'm actually going to start the measurement right now. So I'm going to hit start edge. The first thing it asks me for is to enter the distance. So I'm going to enter in 11.8 meters. Okay. Now I'm going to be collecting data for about 10 seconds. After about 10 seconds, I'm going to hit start moving. So, boom, there you go. I hit start moving. Now, depending upon what boat you're in and how you choose to cross, the basic idea is to go across the river as slow and as steady as possible. Right now I'm along the edge of the river, so the water velocity is very low. So you can hear that I'm actually just idling the boat very slowly across. As soon as I get out in the current, I'm going to increase my boat speed, mainly just to stay in the similar cross section. So what the RiverSurveyora right now, it's collecting velocity and depth data. And it's using that velocity and depth data to calculate the flow as we cross the river. So once I start on this side of the river, as I cross, I'm accumulating the flow until I get to the other side, and I stop the measurement. I collect some edge information, some data along the edge, and then I use that data to estimate the unmeasured flow along the edge, and that gives me my total flow measurement. So now I'm out at a little bit of velocity now, so I'm just cruising across here pretty slow. A good rule of thumb for boat speed is to keep the boat at or below the water speed. Okay, I can look at any time. Again, I can see I've got a water speed of about 75 centimeters per second. I've got good boat speed. I'm just going across nice and steady. One nice thing about the RiverSurveyora, I don't have to keep it pointed in the same direction. It has a compass on board, all right, and it actually tracks the compass along with bottom tracking, or my GPS tracks the position and direction of my boat. Okay, so I can actually go along an uneven course, and it's going to calculate the correct flow. Now you can see I'm in a little bit of a wind right here. The wind's actually going in the opposite direction of the flow, so it makes the operation a little bit difficult. but still I'm just maintaining a nice slow steady speed. I don't have to go straight across the river, okay? I can actually go at an angle, whatever's convenient for me to operate this boat. So now the flow is starting to lower down. I'm getting along the edge, and once I get up near the grass here, I'm going to bring the boat to a stop, or as much as I can. I'm going to measure the distance with my optical rangefinder and input that into the program, and then my measurement's done. Okay, I'm going to hold the boat right here, measure my distance. It's 14.6 meters. I'm going to hit stop moving. 14.6. I'm going to try to hold the boat as steady as possible for about 10 seconds, and I stop. Now my measurement's complete. Now I'm basically ready to go again, so I press start edge. It remembers the 14.6 meters. I can actually check that again. Okay, it's actually 13.7, so I'm going to change it to 13.7. I've got 10 seconds worth of data, so I'm going to hit start moving. Okay, so now I'm collecting data for the transect. I slowly turn the boat out. Again, I've got an opposing wind right now, so it's making things a little bit difficult. But I'm just keeping the boat steady. Again, we're collecting, the RiverSurveyora right now is collecting data about 80 times per second. That also includes the GPS data at 10 hertz. The vertical beam is sampling depths about 10 times a second. We're getting water velocity information anywhere from about 20 to 60 times per second. And we're getting bottom tracking information at about 5 or 6 times a second. So again, here I go. I'm just going to cross a very similar cross section. Again, boat control is the most important. So I'm just maintaining a balance between the water speed, my boat speed. It's always a good idea to keep the angle, the transducer above in front of the boat. That way it doesn't disturb the boat. Another way that I could do this on this boat, I could actually have a mount on the boat and not have to rely on the hydro board. Again, a mount on this boat, I don't want to mount it on near the engine. I would want to mount it near the midship or maybe up here closer to the bow. That's just to keep away from any magnetic interference that might affect my compass. Also, typically a midship on a boat is the most stable point on the boat. So I'm just taking my time. And again, I've got one measurement. When I finish here, that'll make 2. And typically, depending upon where you are, what agency you work for, typically you'll collect anywhere from 4 to 6 measurements and take the average of that as your total flow. So here I'm starting to get close to my edge. Okay, now I'm getting close again. I'm going to get my rangefinder ready. I'm almost in the same location. I'm going to measure my edge distance. 14.6. I'm going to hit stop moving. I'm going to enter 14.6. Collect about 10 seconds worth of data. There, and I'm done. Okay, so what I've just tried to show you is just the basic operation of the RiverSurveyora. Again, the idea of the RiverSurveyora is to measure river discharge. And we can do that any number of ways, but in principle it involves taking the RiverSurveyora M9 or S5 as slowly and steadily across the river as we can, collecting data. A river like this typically would take 4 or 5 minutes per pass. A good idea, a good practice would be to do at least a reciprocal pass from the other direction. And again, just to finish that, typically it's between 4 to 6 measurements as recommended by most agencies.